Exercise 1.2. Let's solve the exercise problems. The first question says, show that the function f from real set of all non-zero real numbers to set of all non-zero real numbers defined by f of x equal to 1 by x is 1 1 and 1 2. Okay. So, is the result true if the domain R is replaced by n with codomain being same as R R star. Okay, let us see. So, it is given that the function is from R star to, so this is certainly they have said, and you see if you that is why you need to have the, I have taught you this function. How does this function? It is a rational function with a, it is a power function with negative with the negative power, right, or it is a rational function. As a rational function, you have to see whether it is a what was I supposed to prove? Is this 1 and 1 2, that is it a bijective or not? Is this, we are checking the bijectivity, check bijectivity. So, how to do it? So, you know that the graph of f of x equals to 1 by x, we need to plot it. So, before we plot, we need to do what? We need to find its, so we need to find the vertical asymptote. So, in this case the vertical asymptote will be at y equals to 0. So, vertical asymptote will be at x equals to 0. What about horizontal asymptote? In this case also horizontal asymptote, we just equate the denominator to 0. So, the denominator x is equals to 0. So, vertical asymptote will also be, we equate it to 0, x is equal to 0. So, sorry, I am doing one mistake here. So, how do we find? We find the, first we find the horizontal asymptote. To find the horizontal asymptote, we equate the denominator to 0. So, here if we equate the denominator to 0, I get x equals to 0. So, definitely this is the curve with x equal to 0 is the y axis only. What about the our horizontal vertical asymptote? To find the vertical asymptote, we make, you can see here, this is there is no x. So, x power is at 0. So, definitely here y will be equals to 0 only. Okay, that means the x axis line, correct. What is the domain of this function? So, if I plot this graph as I have taught you earlier, you will see the graph of this function is something like this. This graph do not have any x intercept or y intercept. So, this is the curve. So, the domain of this function is the domain of this one would be real minus 0. Range will also be real minus 0, right. Now, let us see. So, how to check? And you can see in the question also said R star is that real numbers is a non-zero set of all non-zero real numbers. So, yeah, definitely. So, these are all the, actually the domain is the range is this. So, let us see the function, is it bijective or not. First of all, one injectivity test. Injectivity test. To check the injectivity test, what do? We should make a horizontal line. We should take a horizontal line, and you can clearly see this horizontal line for all values of x. There is a, for every values of x, there is a unique y. Hence, this is 1 1. So, we can write like this for all x. Injectivity test, you can write like this, that I do not have some space to write it. You can write, if I draw a horizontal line on the graph, both on the up and down, I can clearly see that for all x element of, for all x element of the domain, that is R 0, there exists what? There exists an image y, there exists a unique image y element of the range to 0, hence the function is 1 1. Is it onto? To check the onto, look at the graph. Does every value of y has its corresponding x? You can again you can see. So this is y, this is minus y, it has its corresponding minus x, right. So y should be at least image of one element of the x, right, set of x or from the domain. So here clearly y is image. So what we can say? What can we say? That clearly from the graph y element of what? It is y should be the element of the range, right? Y element of the range r real to minus 0 0 is an image of x, element of, hence the function is onto, hence f of x equals to 1 by x is onto, and as well as it is bijective, also bijective, okay. Let us see the next part of it. So clear, this is how we can easily do it. The second part says that if the domain R is replaced by n with codomain being same as R. So here also the codomain, okay, no problem, the codomain will be, let us see now, let us do this. If it is replaced by, how will be the graph? So now it is R is equals to R is changed to what I say, if the domain R is replaced by n. So now n is all natural numbers. So if a is natural numbers, then what will happen, you see. So this is x and this is y, x can only be 0. So f of x is equals to 1 by x, right. So f of x is 1, 0 it becomes infinity. Now if I put here 1, it becomes 1, but if I put it 2, it gives me 0.5. That means we need to apply here the smallest integer function. So if I apply the smallest integer function here, this gives me 1. Similarly, if I take it 3, again it gives me around 0.33, applying smallest integer function, and I get here again 1. Smallest integer function is the, what is smallest integer function? It is the smallest integer greater than or equal to x. So it should be greater than 0.33 is greater will be 1. So it should be 1 we have taken. Now if I plot the graph, similarly it goes for 4, 5 and so on. Now if I plot, what do you see? The graph will be something like this. So the graph will be, now if I take 0, it is infinity. So that means the lines will be coming like this, like this. Now if I take here 1, so this is 1, y is 1. If I take 2, it is again 1, this is 1, this is 2 and so on. So that means the graph will be going like this up to infinity. Remember, you cannot join this portion, you cannot join this portion, you cannot join this, because 0 then it is 1, there is no 1.1 in set of natural numbers. Hence we can say what the function is, the for, hence for the domain as natural numbers, as natural number, there exists y, and or we can say like this, for all x element of the natural number, that is the domain, there exists y, there exists only, you can see there exists only one single y, there exists y, okay. Codomain is R, okay, y element of R minus 0. However, hence 1 1, hence 1 1. However, there is no y. Can you see this is going to plus infinity, this is real, this is also real, right. So, there is no, we can write like this way, for y element of R 0, example minus y element of R 0, there is no pre-image, in the domain N, hence not onto, clear. See how conceptual is it? If a concept is clear, this is so interesting, so enjoying.